Hi everyone, and welcome to the video in section 3.4, the chain rule. So the chain rule gets a lot of hate, but it's a very important rule, and it's also a very important skill to be able to recognize when to use it, especially in Calc 2 when you start learning rules about taking antiderivatives and solving integrals. This idea of being able to understand how composite functions work. What's inside, what's outside. Here's a combination of two functions. What are the two functions? It's really important. So it's going to be important for us to practice this now to make sure that we get it now and we can get it when we're doing things in Calc 2 and Calc 3 and so on. So what's the chain rule? Well, the chain rule deals with having functions that look like a composition. So here's what I mean by a composition. You've got a function f, a function g, and you're composing them together. It's just plug one thing into another, right? What's a common way you might see that? Like square root of x plus 1. This is a composition of two functions. There's x plus 1, and then there's the square root function also. So it's about looking at things like this and identifying, oh, there's two functions there. When you see that, you have to use this formula for the derivative. So the derivative of the composition will be take the derivative of what often I'll call the outside function, in this case the square root, plug back in whatever's in here, just keep it plugged in to this new derivative of the square root. Then once you're done with that, multiply by the derivative of whatever's inside here. Right? So this is what we need to remember. Once you do it a bunch of times, it's really not too bad to do, but it's all about practicing, okay? Now, you see here different notation for this. I'm not a huge fan of this notation. I think it's more confusing to look at, so I would suggest just sticking with this. F prime g times g prime. F prime, I'll even say it a little bit more to emphasize this is not multiplication. F prime of g, got to plug g back in, times g prime. That's a common mistake, multiplying f prime and g here. No, g is plugged back in, just like it is over here, into just f prime now. So this outside function has changed by doing the derivative. This still stays inside it in its new form, whatever that is, and then you multiply by the change of the inside. Okay, so let's just try this and see what happens. Okay, so there's some more description here. So step one of this, what's step one? You got to figure out what f is and g is. What's inside, what's outside. I think the inside's not too bad to figure out, which we call g usually. That's 4x minus x squared. That's the inside function. Okay, so now you just ask yourself, what am I doing to that function? Oh, I'm raising it to the power 100. Well, what's that as a function? Raise something to the 100. Oh, it's just x to the 100. So g is the I think when you look at this, it's like the function you see first usually. It's the inside. And then you got to ask yourself, well, what's happening to that function? Here it's raise it to the power 100. So, okay, x to the power 100. That's it. That's f and g. Okay, so we're going to need f prime, which is 100x to the 99. And we're going to need g prime, which is 4 minus 2x. And then we just need to plug into the formula, like we've been doing the last few sections. Plug into the formula. The derivative of this big F composition function is going to be f prime. Now hold up. Don't write x to the 99 because what's the formula? Go up just a little bit here. The formula says do f prime but plug g of x in. See this g of x here? You got to plug that in to the 99. So this gets plugged in for this x times, now multiply by g prime. All done. That's your derivative. So what are we watching out for? Make sure g gets plugged back in here. Don't forget to multiply by g prime. That's it. Identify, get your pieces together, plug them into the formula. There you go. So step one, Step 2, plug it in step 3. Okay, we're going to just try a bunch of these, so let's keep going. All right, inside, outside. Base kind of function of like, what do you see here, and then what are you doing to it? So f, g, I see 1 minus 2x inside, and it looks like I'm doing the square root to it. Okay, f prime, well, that's just x to the 1/2, right? So the derivative there will be 1/2 x to the negative 1/2. G prime is -2. And remember, I know you're still learning this, and I'm going to go at a certain speed just doing these like smaller derivatives. You shouldn't expect to be at the same speed I'm doing it at. Just pause the video, try it yourself, see what I get. Okay, now plug into the formula. Derivative of this composition will be, take this f prime, but careful, don't put x here. Whatever g was goes in there. 1 minus 2x to the negative 1/2 times g prime. And we can simplify this a little bit. These two numbers combined. This is negative 1 minus 2x to the negative 1/2. Boom. All right, let's keep going. So here is a way to think about this after you've practiced it more that is like a shortcut, okay? So you could see the general idea here. But when your outside function is raising to a power, so for example, when your f looks like, x to the 1/2 or x to the 100 or any of these things, x to the negative 3/5, anything like this, if that's your outside function, then you can just kind of do this real quickly by just pretend this is x for a second. Okay, do the derivative. So drop it, subtract 1. Oh, it wasn't just x. Oops. Okay, let me write that in here. And I'll do the derivative of the inside. So in more complicated scenarios, it is not a good idea to try to do this all in one go like we just did here. But in these scenarios, and again, I think that this is something you want to hold off until you're much more comfortable. You've done more of these. In these scenarios, you basically can just forget that this is even inside here. Do the derivative of x to the 2/3, right? And then just, oops, okay, yeah, plug g back in here, and then, oh yeah, I got to multiply by g prime. And so you don't necessarily, for these ones, have to go through all of these steps. What's f, what's g, put it in this formula, get the f prime, get the g prime. You can do this a lot quicker because it always has the same form. Drop the 2/3, subtract 1, multiply by the derivative in here. Done. Just quick. So again, this is just like a quick little note that you might even see yourself doing as you practice more of these, but is really nice when you can do these out. So starting off, write out the f, write out the g, write out the f prime, write out the g prime, put it all together. But as you get more comfortable, you can kind of do some of those steps kind of all in one, and that's fine. Okay, let's give ourselves some space here. All right, so looking at this, I don't see a very obvious inside and outside. And that's because this is actually a combination of rules. What I see here is I see two functions, right? I see an e to the negative 2t and a cosine 4t multiplied. So that's product rule, right? And so you'll see how we can combine all these things. So g is cos 4t. Okay, and so product rule, great. Now just do your f prime and do your g prime. Well, it's not e to the t, so what do I do? Well, I have to identify here that this is a combination of functions, right? This is just a combo of functions. So we're going to take this off to the side for a moment. E to the negative 2t. Okay. Now, I know I was just using f and g before. We're just going to use different function names because we already used f and g. So let's say that I want to express this as h of j of x. You could just use f of g if you're okay slightly abusing notation. It's not a big deal. So get out of here. So okay, what's inside? Well, negative 2t is inside. Okay, what am I doing to that? Well, I'm putting it into the function e to the x. Or in this case, we could just use t here, e to the t. Okay, so then j prime is negative 2, h prime is e to the t, and so the derivative of this, what we were calling f prime, right, this was f, so then f prime is going to be equal to, well, the derivative of this outside function is e to the t, but wait, don't put t in, you got to put this inside one back, times, and then the derivative of the inside is negative 2. So there you go. We got our f prime by doing chain rule. Very common thing to do. Using one rule, but you got to use these chain rule pieces here. Same thing with g. Same thing happens with g. I've got cosine 4t. I see an inside. So the inside, we'll go I for inside is 4t. We'll go O for outside. Looks not like a 0, huh? I'll put a little like squiggly. O for cosine. So then, okay, I can do this, right? Derivative of I is 4. The derivative of O is, derivative of cosine is negative sine. Okay, I can do this, right? Chain rule. The derivative of the outside function is negative sine, but wait, plug back in the original inside, times the derivative of the inside. Aha! So that's not too bad. Negative 4 sine 4t. Okay. All right, so now what do? Well, we have a formula for this, right? Product rule. So we got to just mix these, right? It's kind of like you got to do these together and then these together. So let's do negative 4 sine 4t, g prime, and then f, plus, and then these two go together, negative 2 e to the negative 2t cos 4t. And there you go. Product rule, chain rule. Product rule and two chain rules all together. So it's a decent amount of work, but take it one step at a time. Focus on the step and the function you're at. Forget about everything else and apply the appropriate rule. Okay, let's try another one. Get out of here. Okay, keep going. So we've got two functions, again, being multiplied. So this is making me think product rule. So f and g. Okay, so then we've got f is t to the 4th minus 1 cubed. We've got then g is t cubed plus 1 to the 4th. Then we've got f prime is equal to, I don't know how to do this one. I need a rule. Same with g prime. Okay, so let's go take f down here. All right. So clear inside function, t to the 4th minus 1. What am I doing to that? The outside, I'm raising that to the 3rd power, right? What am I doing to the inside? I'm bringing it to the 3rd power. So, okay, we could do this. Derivative of the outside, which we can just call, to my fancy O prime, is 3t squared. Derivative of the inside, scoot down a little bit more, inside prime is 4t cubed. Putting this all together, f prime will be derivative of the outside, 3, but not t squared, we got to plug back in, t to the 4th minus 1 squared, times the derivative of the inside, 4t cubed. There we go. So that's 12t cubed, t to the 4th minus 1 squared. G prime, okay, so I'm going to do this one a little bit quicker. You could pause, see if you can do it too. Derivative of the outside. Well, the outside is t to the 4th. So that's 4 but I'm not going to put t in here, right? I got to plug in with the original. And then I have to multiply by the derivative inside, 3t squared. So that was me kind of using that rule above, that kind of all-in-one idea to try to quickly do this. So that's 12t squared, and we've got t cubed plus 1 cubed. Okay. I don't think I left myself enough room there, so we're going to tell you to get out of here. And then we're going to put this all together again using the product rule. So h prime of t, product rule. Remember, we've got to do this and these together. So let's see if we can remember this. That's t to the fourth minus 1 cubed. I'm going to do a lot of scrolling. T to the fourth minus 1 cubed. 12t squared, and then t cubed plus 1. So 12t squared, t cubed plus 1 cubed, plus, now, right, we did this one, we got to do this one. T cubed plus 1 to the fourth times 12t cubed, and then t to the fourth minus 1. 12t cubed, t to the fourth minus 1, and that's squared. Woo! Got it. Product rule. Overall, inside the product rule, I've got to do a couple chain rules for these. Okay, so with this next example, we see again a composition, but also now a quotient in there. So immediately you see a division. I probably have to use quotient rule, but it's not just that. I've got this extra composition. So what do I see inside? Inside, I see x squared plus 1 over x squared minus 1. Okay, then, what do I now see on the outside? Well, on the outside, what am I doing to this? I'm cubing it. So your F can just be the question or the answer to the question, what am I doing to this inside? All right, F prime is 3x squared. That's not bad. G prime, on the other hand, though, this is where the quotient rule comes in. Okay, so low, D high minus high, D low over low squared. Boom. You got to just use your rules. Okay, so then how does this work? Well, remember, this is overall chain rule we have to do. Your outside function, take its derivative. So then this is going to be, the derivative of this will be 3, and then don't plug in x squared, right? You got to plug g back in. X squared plus 1 over x squared minus 1 squared times, and then now we've got to do this g prime. So you can just leave it like this. You might want to do a little algebra, just kind of playing around here. We could factor a 2x out. Let's just look at the top, just the top of this. So that's 2x factored out, x squared minus 1 minus x squared plus 1. Okay, so, that's going to be nice. The x squareds will go away. This will be negative 1 minus 1 is negative 2. So the top actually becomes negative 4x, all the way simplified down. So a little algebra can be nice sometimes. Not necessary if you're just playing around with this by itself. But again, think about having to use this to find the slope of a tangent line somewhere. You want to plug into this terrible, nasty thing? No, I'd rather plug into this one. Done. There you go. Little quotient rule in here, overall chain rule. Just follow the rule. Okay. Haha, this one looks good. So let's go here. We see secant squared x and tan squared x. So plus sign means do this separately. So the derivative of this, and sometimes we kind of skip out on doing this step, but I'm just going to remind you and rewrite it. This is secant squared, do that one, then do the derivative of tan squared. All right, we take this for granted and just kind of split things all the time, but just writing it out is nice sometimes. Okay, looking at this, secant. Oh yeah, I have that list of them I can go back to, but it's secant squared, not just secant. Okay, well, we had that rule above, right, that said if you're just taking a function to kind of like a basic power here, 2, 3, 1/2, -5, whatever, then that power is just going to be your outside, and whatever in here is your inside. So really this can, again, write it all out, but it's not too bad to get used to this. 2 secant x times, because this is now a 1 power on here, the derivative of secant, which is secant tan. All together, this is going to be 2 secant squared tan x. So I'm doing chain rule here. The outside function is square something. The inside is secant. Okay, what about this one? Very similar. 2 tan x. The derivative of tangent is secant squared. And that one doesn't have as nice of a simplification. But what do I end up seeing, which is kind of neat? Check this out. These are actually the same thing. So this is actually just 4 secant squared tan. Boom. Got it. Okay, so hopefully that's not too terrible. Let's try this next one. Cotangent. Whoa. Okay, we can deal with this. So first things first, what's happening here? I'm squaring the cotangent, and I've got a sine inside. So let me rewrite this so it's a little easier to see. This is cotangent of sine theta squared. So, okay, well, this is a little tricky, but just kind of start right away. There's an inside and there's an outside. So let's do it. The outside looks like something squared. I'm using theta because that's the variable here. The inside looks like cotangent of sine theta. Okay, so all right, that's not bad. I wanted to do quotient rule here. So f prime is 2 theta, got it. G prime is, oh, this is not trivial. I've got to do something here. And guess what? It's a chain rule. Look, I've got an inside function and an outside. So my inside function, so now we're just doing this g prime. The inside function is sine theta, and the outside function is cotangent theta. Aha! So, okay, you know, we can do this. I prime is cos theta. Derivative of cotangent, right, is negative cosecant squared theta. Okay, I can do this. Chain rule, right? Chain rule. So put this over here. G prime is going to be what? G prime is going to be, well, the derivative of your outside function, negative cosecant squared, plug back in what you had, times the derivative of the inside. I know these get messy, but you just got to follow the rules, follow the formulas. So that's your G prime. Okay, so then overall, we're now back to the overall chain rule with this f and g we were doing. We just did a mini chain rule for g prime, but now we've got fg, f prime, g prime. We got to do this bigger chain rule. So okay, let's do that. The bigger chain rule was what? The outside function was something squared, so the derivative f prime is 2. Now, I can't write theta here. I got to plug back in whatever was in there before. Okay, now that's to the 1 power, but we can just leave that off, right? This is a 1. Okay, and then I multiply by the derivative of the inside, which was g prime. So this is going to be negative cosine theta cosecant squared sine theta. It's big. I'm not going to pretend like this is not some, you know, kind of crazy thing we're doing here. It is. But, you know, the answer looks crazy, right? But, you know, each step hopefully wasn't too bad. The G prime was just a one-step chain rule. The overall problem was a two-step chain rule, 2 chain rules. But what does 2 chain rules do? It just breaks down into Well, 2 chain rules. Just do 1 chain rule at a time. You don't have to do everything at once. So hopefully not too bad. Okay, let's bring this back up. So this process actually gives us an entirely new set of derivatives. And if you're interested in going through this, doing the chain rule, go for it. I don't care if you can, show this at any point. I'm never going to ask you to show this is true or anything on a test. But this is just a new rule that you have to learn. The derivative of a to the x. So just as a reminder, we know the derivative of e to the x is e to the x. But if a, this number here is not e, something else, 2, 3, pi, whatever, then the derivative of this is going to be, well, a to the x. So okay, that kind of matches. But then natural log of a is multiplied in front here. So, of course, if you're looking at this formula, a can't be anything, right? We have to make sure that the natural log of a is defined, which means you can't have 0 or a negative number for a. But besides that, all other a's you could think of, we can do this. So, pretty nice formula to have. Opens us up to lots of functions. The common ones are stuff like e to the x, which we already had, things like 2 to the x, 10 to the x, stuff like that. These are kind of common ones we want to do. And so the derivatives of these, right, the derivatives would be e to the x, ln 2 times 2 to the x, ln 10 times 2 to the x, where the ln is the natural log. So just another formula to have in your head. Okay? So hopefully that's not too bad. Lots of stuff going on here, right? But you just got to take it step by step. What am I doing here? What's the rule I need? Let's just do that one rule right now. Forget about everything else. And then once we've done that, put it back together and keep going. Any questions, of course, let me know. And I'll see you in the next video.